we are going to draw hydrocarbons. Drawing hydrocarbons will seem fairly simple and intuitive after naming hydrocarbons. You will need tables P and Q. Our first step is we determine how many carbons are present in the parent chain, or the carbon backbone as it's also known. We do this based on the prefix in table P. So if we're looking at pentane, for example, pent is our prefix, which means we have 5 carbons. 1, 2, 3, 4, 5. I always start with just single bonds. If I need to add double or triple bonds, I can do that later. Step 2, I need to determine if there are any multiple bonds, meaning double or triple bonds, based on the suffix of the name in table Q. Fill them in on your carbon chain using the numbers given. Since I have an ane ending, that tells me that I have all single bonds. So I don't need to worry about step 2. Step 3, determine the identity of any substituents and their locations and add them to your carbon skeleton. In my name, I simply have pentane. I don't have any methyls or any ethyls, so I don't need to worry about that. Step 4, fill in hydrogens. Every carbon holds 4 bonds. So the bonds between the carbons are each going to count as 1 since these are all single bonds, and then we'll fill in hydrogens from there. On my first carbon atom, carbon number 1, I currently have 1 bond. I'm going to add 2, 3, 4 more bonds. So I can now count around my carbon 1, 2, 3, 4 bonds. On my next carbon, I have 1, 2 bonds that are attaching the carbons. So 3, 4, we'll fill that up with H's. 1, 2, 3, 4. The next carbon, 1, 2, 3, 4. 2 bonds on the next carbon, 3, 4. On my end carbon, I currently have 1 bond, so I can add 3 hydrogens. Methylheptane. Hept is the prefix that tells me how many carbons I have in a row. 1, 2, 3, 4, 5, 6, 7. Next, I'm going to look for any multiple bonds. I have an ane ending, which means I have all single bonds. I do, this time, have a substituent, 2-methyl. So I'm going to count in 1, 2 carbons. And that's where I'll attach my methyl group. You can count from the other side, but as a rule, I usually go left-right, just to help me be consistent. On carbon 2, I'm going to attach the substituent. A methyl group, if you remember, is a CH3. Meth means 1, so we put 1 carbon there. And typically, this would have 3 H's on it, because every carbon has to have 4 bonds. So you can draw this way. I actually like to tend to draw it like this to help it fit a little bit more easily in my molecule. I'll erase these numbers so they don't get in my way. So now I've taken care of my substituent and its location. My last step is making sure all carbons have 4 bonds. One thing that you are allowed to do is simply show stems representing where the hydrogens would be. So it is assumed that all of those stems represent hydrogens, and now I'm all set. You do have to be careful and make sure that you always have your 4 bonds. Just to do a little quick count, we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Very redundant process, but you'll get in the habit of doing this quickly. Our next molecule, 3-ethyl 2,4-dimethyl octane. Oct means 1, 2, 3, 4, 5, 6, 7, 8. 3-ethyl means on carbon 1, 2, 3. We are going to put an ethyl group. An ethyl group has 2 carbons in it. The first carbon is able to fit 2 hydrogens. The second carbon fits 3 hydrogens. A nice way to condense this is CH2, CH3. I'm showing this at a bit of an angle, more for the sake of making sure that it fits. It is important to make sure that this bond is attached to the carbon with only 2 H's on it, and the CH3 is still on the end. Next, my next two substituents are 2,4-dimethyl. So I have to have a methyl group on my second carbon. You can put this up or down from the other group. It doesn't really matter. So I'm going to put my methyl group down. On my carbon 4, I'm also going to choose to put my methyl group down. Really, my reason for choosing to do so is I don't want to end up with crowding in this area right here. If I put the methyl group up, it might bump into my ethyl group, and I'm trying to avoid that. Next, I have to go through and fill in my hydrogens. On my first carbon, I have room for 3. On my second carbon, I already have 3 bonds, so I only have room for 1 more. Same thing on my third and my fourth. Be very sure that this bond does not connect to this CH3 up here. You don't want any contact between that bond and that ethyl group. I'm going to continue to fill in my H's like we did in the last several examples. 1-pentyne. Pent tells me I'm going to have 5 carbons in a row. My ine ending tells me I have a triple bond according to table Q. That triple bond is going to be at my first carbon. So this one is talking about that ine ending and where that triple bond will go. You can number from either side. 1, 2, 3, 4, 5. If I number from the left, which is what I choose to do. My triple bond should start at carbon 1 going in the direction in which I numbered. So my carbon bond, my triple bond, is going to start at carbon 1 and extend to carbon 2. When you have multiple bonds, you have to be careful when adding your H's. Currently, I have 1, 2, 3 bonds to my first carbon. I only have room for 1 more H. On my second carbon, I have 1, 2, 3, 4 bonds already. I don't even have room for any hydrogens here. Then it goes back to normal. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. For octene, octene is 8. On carbon number 1, 2, 3, 4, I'm going to start my double bond. Now I simply have to go back. I don't have any other substituents to deal with. I simply have to go back and fill in my H's, which I will do using the shorthand model. On my double bond, I have 1, 2, 3 bonds to this carbon, and 1, 2, 3 bonds to this carbon. It does not matter if you put those lines up or down. They go the same way or different ways. There's a distinction about this later on, but we do not worry about that in high school chemistry. And I complete my diagram, making sure each of these has 4 hydrogens, or I'm sorry, 4 bonds on every carbon. Here are a few for you to try. Pause the video, and the answers will be displayed in a moment. So your first structure, propane, is simply a 3-carbon molecule with your all single bonds and H's extending off of each carbon. Remember that each of these are representative of an H. I do find it much easier to use the stems, and I encourage you to do so. Just for the sake of the visual, that's what those H's look like. In 3-heptene, we have carbon 1, 2, 3, which is where we begin our double bond. You can choose to number from the other side, in which case the bond would appear to be in a different place. In ethine, we don't need a number because the triple bond has to go between the only 2 carbons that you have. After that triple bond is there, we only have room for 1 hydrogen on each carbon. In 2-butyne, this is carbon 1, 2, and once we have that triple bond in place, 1, 2, 3, 4 bonds on each carbon, 1, 2, 3, 4 on this guy, so we don't have any H's there. Please be sure that you don't put too many H's on any carbon. 3-ethylpentane, 1, 2, 3 That's my third carbon. If you outnumber in the other direction, that will still be your third carbon. Remember what an ethyl group actually looks like. If you imagine this is your carbon stem, carbon chain, it's two carbons coming off, one of them holding two hydrogens and the other one holding three. So it's very important to make sure that the carbon that is connected to your chain has two hydrogens, whereas the carbon coming off that one is your end carbon with three hydrogens. Also, be very cautious that this bond right here does not attach to that structure. You can write this at a little bit of an angle to help it fit. 2,2-dimethylhexane, 1, 2. You do not want to number from different directions. You might be tempted to put one carbon or one of your branches on this carbon and then maybe another one on that guy because he'd be carbon 2 if you went from that direction. But that's not how we do things. We got to always number from the same direction. Once you've committed to that being carbon 2, the 2,2 is actually telling us that both of those substituent groups are on the same carbon. The last one I gave you is a bit of a challenge because this 4 right here is actually referring to that double bond. So a carbon 1, 2, 3, 4 is where we have our double bond. We have 9 carbons in a row. On carbon 2 is where we have our 1 carbon methyl group right there. On carbon 3, we have our 2 carbon ethyl group. I chose to draw that a little bit more structurally, but this could also be represented as CH2, CH3, and this could be represented as CH3. Completely equivalent, doesn't really make any difference.